In today's tutorial, we're diving into the power of open source language models to revolutionize how we record and transcribe meetings and other communications in real time. Have you ever dreamed of your own AI co-pilot that listens together with you and then can summarize, translate, or give tips in real time? Let's dive into building exactly this in the next few minutes. You have probably already heard of OpenAI's Whisper that allows speech recognition in a high quality. While this method is excellent for transcribing meetings, podcasts, or any form of spoken communication, it's important to note that it can be quite slow. Thus, you'll learn about an alternative. With incredibly fast Whisper, you have the capability to convert speech to text in real time. I'll guide you through a straightforward and cost-effective method to access this language model, and indeed, all open source models on Replicate. We'll develop a recurring loop designed to continuously capture small audio segments every 2 seconds and send them for processing to achieve near real-time transcription capabilities. Our project involves constructing a compact web server that enables direct recording in the browser. This setup will then segment the audio into 2-second chunks and send these to the backend. Once uploaded, these segments will be automatically transcribed and the transcription will be sent back to the web page. In just 5 steps, we'll build your own transcription co-pilot. It's designed to be easy to follow, and you'll have access to the source code. Let's start by exploring Replicate. You can sign up for free using your GitHub account. Once you click on Explore, you'll find a list of available open source language models ready for various use cases, all of which you can try out at no cost. Moving on to the programming part, we need to have Visual Studio Code and Python installed. First, we create a virtual environment to manage our project's dependencies separately. Then we make a new file named app.py. The first step is to connect to Incredible Fast Whisper on Replicate. We look up Incredible Fast Whisper from the provided list. On the detail page, you'll notice detailed instructions on how to use it with many programming languages. And we follow the instructions for using Replicate with Python. Just copy these instructions. Our first task is installing Replicate, followed by importing it into our script and pasting the example code. We notice there's already a hard-coded reference to an audio file. Let's take a listen.
The little tales they tell are false. The door was barred, locked.
Now we're ready to test our script, but remember, we might encounter an error message because the authentication token hasn't been set. We need to copy and set this token from Replicate's site. After setting the token, we try running the script again. And voila, we see the model translating text. Perfect. Now we want to work with our own sound files using Replicate, which requires accessing AWS from our Python script. First, we'll use the library Bodo3. Let's import it. We can now create a new bucket at AWS. The prerequisite for this is that we have an account here, but that is created in seconds. Under Services, we can now click on S3, and from here we can create a new bucket. As the name for the bucket, we specify AI for devs, and we allow public access. For this, we have to confirm that it can really be accessed from the outside, and then we can also create the bucket. Next, we have to set the permissions correctly again, and for this, we add a bucket policy. A bucket policy defines who has access to the bucket. This can be copied from the description. In effect, we allow complete access for authenticated users to all contents within our new bucket. Excellent, we now have a secure location for storing and accessing our files. We can now also copy our sound file into this new bucket so that it is available for Whisper. After configuring the policy, we specify our bucket's name in our script. Using the Bodo3 client, we can access it using the AWS Access Key in secret. To create them, we go again to the AWS console Here we click on IAM for identity management, and under users, we already see our administration account. To create a user with restricted access, press Create User, enter AI for Devs as the username. Next, we attach a policy that defines the specific rights. This policy should limit the user's permissions to directly use S3 and grant them restricted access to designated S3 services only. Let's generate an access key. The access key enables our Python script to authenticate as the AWS user. We give it a short description. We can now copy the access key and use it in our script. Let's also copy the secret access key. Keep in mind, in real projects, AWS credentials should never be stored directly in the source code. In my case, I've already deleted these demo credentials. We then enter the file name and can now actually upload the file. The URL of the file results from the bucket name s3amazonaws.com and the file name. If we embed the file's URL directly into our replicate call, we can test if the transcription works. Okay, perfect. We've successfully transcribed our pizza voiceover. Next, we want to be able to record texts via a web interface as well. For this, we first install Flask. We import Flask, request, JSONify, and render template. We also import temp-file. Then we create a new server with Flask and say that under the default route, an index page should be delivered. For this, we use the method renderTemplate and serve a index.html file. We create a new folder templates and in it the index.html. Here we can first place a simple hello world to see if everything works. Before starting our Flask server, we execute the command to launch the application on all available IP addresses of the host machine, making it accessible on port 8080. We start the server. Okay, great, we see our hello world. Let's paste our prepared HTML code. Our interface features a record button to initiate audio recording. Additionally, there's a text area displaying transcripts in real time. At the bottom, we incorporate a JavaScript import responsible for managing the interface's behavior and facilitating communication with the backend. Flask expects assets to be served from a static folder. Therefore, we create this folder and within it, a subfolder named JS. Our script.js file is placed inside this JS folder. Let's paste the prepared JavaScript logic. First, we obtain references to the record button and the transcript display area. Next, we attach an event listener to the record button to monitor clicks. Initially, clicking the button starts the recording process, and clicking it a second time stops the recording. In the start recording function, we asynchronously request access to the user's microphone, capturing the audio stream once permission is granted. Within the create recorder function, we initialize a media recorder with the audio stream, setting it to capture audio data. As audio data becomes available, it's packaged and sent to the server via a post request for transcription. The received transcript is then added to the ongoing transcript displayed on the web page, allowing real-time updates as more audio is processed. Upon creating the recorder, we establish a routine to periodically stop and restart the recording every 3 seconds, enabling continuous audio capture in manageable segments for processing. To halt this process, the stop recording function clears the interval and stops the media recorder, effectively ending the audio capture session. In our backend, we require an additional route to handle the JavaScript request carrying the recorded audio. We establish a new route named Process Audio. Within the corresponding function, we start by extracting the audio data using request.files audio.read. To facilitate uploading to the AWS bucket, we generate a temporary file into which we write the audio data. The temp audio write audio data line writes the raw audio data into a temporary file. Temp audio flush is called to ensure all written data is immediately flushed from the internal buffer to the file system. Following this, we proceed to upload the file to S3, adjusting the URL accordingly. The final step involves returning the generated transcript in JSON format, making it accessible for further processing or display in the front end. Now we have everything set up. Let's cross our fingers and hope for the best.
So, I'm happy to be here. It's very nice to see all of you. You're all looking well.
Today's a Women in the Workplace thing. Jan's coming in from corporate to talk to all the women about...
Everything works perfectly. Let's celebrate what we've accomplished in the last 10 minutes. Don't forget to like and subscribe if you want to be notified about our new videos. Your support is crucial in helping us continue creating valuable content for you. Thanks for watching.